There we go. Sorry about that, guys. I didn't realize I was muted. Shoot. But I guess I'll just reintroduce what I was talking about. So, yeah, I haven't streamed for a long time, guys. I felt as if whenever I streamed math content, I felt as if I wasn't studying much of the material. In addition to, I felt like I wasn't doing a good service for, like, I guess the math community, because I felt as if like I wasn't at a level where most people would want to watch math content from me, because like I don't have a PhD in math, I don't even have an undergrad in math, and I just love the subject. But in addition, I know a lot of people want to watch math content to get clarity on how they're thinking about a problem, or how is it that they're supposed to think of a problem. And I know a bit of algebra and I know a bit of calculus, but at the same time, I could probably tutor a little bit about those. But at the same time, I like to get into higher levels, such as proofs and probably like maybe mathematical physics, but I know I'm nowhere near that level yet. So while I was not streaming, I just basically just studied on my own and tried to better understand how I learn things and better understand how I can implement new ways of getting information and researching without cramming a lot of textbooks in my head. So that's basically the gist of it. Yeah, again, apologies that I was muted before. It's been a while since I've streamed on this channel, so I thought I would get back to talking about what I was talking about. So I think the point of the stream is just to summarize, I guess, my thoughts on, and hopefully when I summarize my thoughts to you guys, it will help create a bridge where you guys feel like it's, I would have to say, let me see here. Let me check here. Just tune up the just basically turn down the music. Yeah, I just lowered it down a bit, because I'm actually hearing what you're hearing. The only thing I can't hear is my voice, because I don't like hearing my voice when it's relayed. It's better now? Okay, cool. Yeah, so, so getting back to what I was explaining before, I'm trying not to make it a lecture, but at the same time, I guess I can't think of another way to make this stream / video other than I guess sort of like me summarizing my thoughts in a way. I think a lot of people, when they look at math, like especially during high school or during their formative years, like in primary school, they look at math as just a calculated tool, and once you master the calculation aspect of it, you'll be able to be like a genius at anything. But at the same time, that's not the case when you get into higher levels of math. So what I notice about people when they make content on math and physics, or both, and when they try to make a bridge between math to theoretical physics or mathematical physics, it always comes like the intent is good, because they try to explain it in a way where they give you the branches you need. But I feel as if like giving it to someone who is not in university, it feels as if they're not really ready for it. It's like they've already been thrust into something that they can't really like fully grasp, because they don't have a bridge that leads to where they were. Such as people that are in high school, I think that people in high school that are interested in theoretical physics, they really want to get to a point where they can actually look at the equations and somehow translate. The problem is that they haven't developed the thought processes of understanding proofs to actually get to the level where they can use the math to kind of, I guess, underline the physical foundations of what they want to build to explain, if that makes any sense. So, I felt as if like all the videos out there basically explain it to people that are already in university level, whilst the whilst the videos are great for people that are in university and they probably have a good idea of what mathematical proofs are, or at least have a vague idea about it, they don't really help kind of bring in people that are like at the high school level and help people in high school or primary school look at how proofs can be developed in a way that builds the rational numbers and builds the integers and builds like the real numbers. So, oh, thank you. Trying to see your name because like I guess I'm getting blinder a bit. Philofi, if that's your name. Hopefully I pronounced that correctly. Yeah, I found this background like a while ago because I felt like I just wanted to make it a little different. Usually I have like I think I have a nebula or a cosmos behind me, but I just felt like changing it to more mathy. So hopefully that doesn't bother you guys, or if it looks great, then I guess I picked the right background. Well, most people say fluffy or floafy. It's fun to see how people say it. And that's fun. You know, I think that's the reason why people pick unique names. But yeah, that's the reason why this I wanted to stream because I won't be able to stream the rest of this week. I don't know when the next time I will stream, but I felt like I should just get back into actually trying to make some content for you guys, because while I was gone, I noticed that a lot of people were starting, well, not a lot of people, I would see like 1 or 2 people sub to the YouTube channel, and I felt as if I don't want to let down my math and physics peeps out there. So I just felt as if I should just get back into it to show that you guys are still like appreciated. What kind of maths do you do? Well, the thing of it is that for me, I just like learning a lot of different branches of math. I like learning about proofs. I like learning about calculus. So I jump back and forth between calculation-based math and proofs. But I felt as if with this stream, I wanted to kind of talk about bridging between high school math and proof-based math, because whenever I look at videos on YouTube, I would see that a lot of people are either talking from this perspective or people are just reviewing from this perspective, but they don't really go into the bridge, or they don't really start with the mindset of someone starting from here to here. And I think that's the thing that I wanted to touch upon with this stream, actually. Although I am not an expert, I am not a professor, I don't have a PhD in math or anything, I just felt as if this is maybe something that people that are hobbyists like me can implement, whether you're in high school or whether you're in university. So, or whether you're already doing your PhD or something. Like people that have a PhD in math and they know a lot of math already, maybe you guys can give me a better way of actually explaining it, because I'm not at your guys' level. If you already have a PhD or are already in grad school, if you already have an undergrad in mathematics, like a bachelor's degree in mathematics, then you probably will do better in explaining it to me, the material, probably a lot better than the way I could. Because I would read books and I would try to summarize it in a way that makes sense to me, but it might not make sense to everybody. Or maybe I read a definition and I think I know it, I understand it, but maybe I misunderstand something. And that's usually how it be. So, just have a bachelor's, I'm trying to go for a master's. Yeah, yeah, the thing of it is that if school wasn't so expensive and money was no issue, I probably would still be in university, just learning everything I could. That's probably how selfish I am when it comes to like learning stuff, but me, I have to resort to just learning from books. So, because when I look at proofs, when I actually look at proofwriting, or at least like the basics, like intro to proofwriting, I feel as if we could teach it to high school students, because high school students have, like, you know, grew up doing calculation-based math, and like once they learn proofs, they start to get an idea of how math is constructed. And because high school students are already so used to like abstract ideas, like definitions that talk about like, you know, abstract things, Like, what's a big vocabulary word that would mean something abstract but we can understand as adults? I'm trying to think. It's like stuff when you learn like a big vocabulary word that means something, but when you translate it, when you actually use the definition, you realize, oh, okay, it means something that simple. But of course, with math, it's not put as simply. But I feel as if it could be leading towards that, you know. Parental. Yeah, I don't even know what that is. Yeah, probably to highly motivate high school students for sure. Yeah, because I think the thing of it is we're teaching students how to do math, but we're not teaching them how to create it. So in the description down below, I put down a couple of links. So the thing of it is that with math, if you actually start with proofs, you begin to see how the numbers are constructed. But I think the thing that's kind of like burdensome about math is that you have to learn how algebra works, and a lot of people don't like learning algebra, or even geometry for that matter. So I put a couple links down below in the description of the YouTube description, so you guys can actually like click on those. If you're watching this on Twitch, I will post these in Twitch on the Twitch chat, so you guys can actually like take a look at them for yourselves. Because when I started learning how to build these things, build like the integers, like I haven't fully understood them yet. I'm just basically taking the works that I've kind of like try to look up on my own based on curiosity. Hey, Unstunky, how's it going? Yeah, I'm just basically trying to get back into the streaming game thanks to our YouTube fam. We built a little bit one by little on the YouTube fam. So since you guys were so nice enough to sub, I thought that you guys deserve like some streaming. But yeah, I'm trying my best here to basically we did not get into Waterloo. Yeah, I felt like I should just have the face cam up, because if anyone's going to like, you know, be like explaining things, like trying to act like a tutor or something, I thought I would treat it like a one-on-one tutoring session or something like that. I don't know. So I felt like I should just show my face. I mean, it didn't bother me to do that because I've done that with my gaming channel, but at the same time, there were times when I just didn't want to show my face because I just didn't want to wear my good glasses. Because at home I always wear my home glasses, and my home glasses would have a crack in it. So I'm like, I don't feel like showing my face on camera. So, you know. Oh, you guys know each other. Great, great, great. It's all good. We'll figure something out. Or we. Hello, Linda 10. Welcome, welcome, welcome. Welcome, guys. Welcome, welcome, welcome. Anyone that's new here, please come in, come in, come in. I'll figure out the recipe to break through the matrix. I mean, like, that's the thing that surprises me most, is like whenever I stream math, like people that are higher levels than me, that have PhDs or are working towards their PhD or masters, I find it very, very humbling that you guys stop by the channel, because I always feel as if like I feel like I'm nowhere near your level, and yet you guys just stop by anyway, so I'm kind of thankful for that. But anyway, I think like I said, the point of this stream is just to get from high school level math to kind of getting into the thought process of getting into proof writing math, because I'm finding math content all day, every day. Yeah, you know, and I know there's a lot of like people that can explain the content much better when it comes to like math content. So I know I'm not going to be like on that level. I'm just trying to like get to people that are inspired by math and who probably are not planning to be a mathematical professional into it, because I'm not a mathematical professional. And that includes people that are in STEM, actually. So, the thing, what I've discovered over the course of not streaming for a while is that I know that, or at least I've learned that with trying to use math to build the numbers, so math to build the numbers, from what I've read and I've kind of like scour around, because with my studying I've been trying not to make it so that I just look at a textbook and I constantly memorize stuff. I'm trying to make it so that I would read the textbook but not memorize as much, and try to recall what I've kind of connected with. So yeah, I just felt like putting my face to the camera, because I feel like I want to make it like a one-on-one type of thing, where it's like if you guys ask a math question that I can answer, I can probably just write it down and you guys can see my reactions. But at the same time, it's more interactive this way. So that's why I kind of made it this way. So like from what I've learned, like to use math to build the numbers, you obviously need logic. But of course, there's two ways of looking at it, because you also have sets. And for the longest time, I always wondered, why is it that some books start with sets and why some books start with logic? And I always end up wondering, why is it that logic can lead to sets, but sets sort of have this weird way of actually just kind of being introduced, but then logic is sort of like the next chapter, but you kind of don't see the relationship between them. And maybe we can go into that today, I guess. Because like for me, I can understand where logic leads to sets, but when it comes to sets, it always feels as if like when it's first introduced to you as chapter 1, it feels as if it kind of goes around it, and then you won't get into logic until it's like chapter 2. But you kind of feel like it's a different topic, and maybe those that already are knee deep in math proofs can explain that to me, because I don't understand. I understand from logic to sets, the build up to that, because it feels as if it's kind of natural. But when it came to just starting with sets at chapter 1 and then going to logic at chapter 2, it always feels as if it's like it kind of feels like logic is just crammed in there, but it has nothing to do with sets at all. I think the book that I've read before, How to Prove It, I think that introduces logic, and then it goes into sets like in between the chapters of logic. So I think it has something to do with like the axioms that you use to build the natural numbers, such as I don't know if I'm gonna spell it right, axioms, and then the ZFC axioms. I'm not gonna write the axioms out, but these are like the two axioms that I kind of became familiar with. I wouldn't say I memorized them all, but at the same time, I feel as if this is like the starting point of where you actually get to learn what the numbers are. But of course, like if I've lost people, please tell me that I got you lost. So what you guys type? I just want to, and basically my streams are like interactive, so I try to make it seem like we're kind of researching math together, not like, oh, I'm doing math homework and you guys are just studying with me. It's more like, I think of it as like we're researchers and we're just kind of like going back and forth on what is it that the math and the physics are telling us, That's basically how it is. Even for basic physics and math problems that already have answers in textbooks, I try to make it as engaging as possible, where it's like we're in a classroom, but we're not really doing it in solitude, we're doing it together. And I think that's not done enough in math, actually. actually, like working on stuff together. Unless you're like already like a professor or you're already a mathematician, as far as I know. But for anyone that's more experienced in research or being a mathematician or like being exposed to that environment, please like, like correct me if I'm wrong about that. Let's see. Logic in introductory text gets talked about in the service of proof techniques usually. It makes it easier to see, for instance, why something like proof by contradiction works out, or how to properly negate qualifiers, right? Anytime you talk about operations on sets, you're going to need logic to implement them, though. Most of them are defined in terms of comprehension notation, right? For example, the union of A and B is usually defined as all elements of A and B, or both, which is just informally described. The set comprehension. Yeah, like for me, whenever I read something like a mathematical proof book, I would love to see it in simplified notation, like in set notation. But then again, like if it's in logic, I love it when it's like labeled, where it's like there's a lot of tables. Like if I was reading a book, I would love it when they listed out like the symbols. So like that this is and, this is or. Bring this down a bit. And what else? Oh yeah, and this is the negation one, or the not one. And this one is implies, and the biconditional one. And then when you get into truth tables, it gets a little bit interesting. Before you type something, let's see. Oh, you guys, let's see. I view the separation as more of a context or a paradoxical boundary rather than a logical discrepancy boundary. Yeah, I think it's because like I just wanted to ask, like, why is it that because like some proof book starts with sets and some books start with logic, and I feel like the ones that start with logic kind of have a better flow, I think. But at the same time, I know why. I kind of understand why they would start with sets, because it feels as if like you're kind of going, I guess, into another school of thought. Logic and sets are strongly related. For example, the set A union B contains all elements that are in A or B, right? Likewise, the sets A intersection B contains all the elements that are in A and B, right, yep. More advanced books tend to skip the logic intro and assume readers are familiar, right, yeah, that's also true too. You can think about how the Venn diagram for implication looks like. Right, yeah, because like I feel like with like when you start with sets, it kind of, I guess it does, like you said, Fluffy, it feels as if it's kind of assumed. Yeah, the logic is assumed that the reader knows it. But at the same time, I feel like with logic, when you start with logic, you have to go into truth tables, and the truth tables are fun when it's small, but when it's like too big, it just gets too cumbersome. Yeah, like the fun thing about like truth, like I think with truth tables, like or I feel like with logic, when you actually start, I guess, teaching students like about how to make proofs, and you start with logic, it kind of feels like a philosophy course rather than a mathematical course in some way, because you're teaching students how to think at that point, such as if you have a statement P and Q, and then you have like the P and Q. If you have both are true, then this is going to be true. But then if you have one that's true and one that's false, then basically it's going to be false. And if you have one that's false and one is true, then that is false. And then if you have both of them are false, then this is false. And usually you'd be doing that for the first couple of problems in like logic. I sometimes don't end up doing all the problems because I get a little bit bored just writing truth tables over and over. But I'm pretty sure a lot of people that do intro to math probably are used to that. Because I'm also trying to develop a new study routine where it's like I can study for a half an hour and get a lot out of it, than rather study for 3 hours and get nothing out of it and don't remember anything. Because I guess to be an intellectual, or less someone that really wants to learn about stuff, you have to like try to develop this habit of not having to constantly cram stuff in your head. And even though you were aware of your blind spots, like there's a way to make your blind spots like more for you to actually remedy your blind spots without having to constantly ram a lot of information in your head or memorize a lot of things. I tend to use truth tables only until I've built up enough useful substitution rules, and then drop the truth tables, right? Actually, when I think, like a thought came into my head where it's like, you know how you have units in physics? I kind of feel like truth tables are kind of like math's version of dimensional analysis. So I guess I'll just write that there. Truth tables to physics dimensional analysis. And sometimes like people would like have these similes or like these what do you call it, these comparisons, but they wouldn't think anything of it because they think it's just random. Like I know I have them, but sometimes they help me solidify, I guess, the technique or the feeling of the math, so it's like more personal, I guess. Yeah, this is an interesting conversation to me. I'd never thought much about what the choice of the first chapter suggests the author thinks about their relationship to the reader, but it makes a lot of sense. What makes a lot of sense in Stunky? Like how they set up the chapter for the reader, or is it something else that I'm not thinking about? But that's more of a personal opinion. I find them rather clunky. Like, is that about the truth tables? I'm probably way behind on chat because you guys are just being so active and I'm loving it. I think they're a really good tool for students, though. They're very convincing because they represent arguments and checking. Yeah, I guess like if you're a debate club or whatever, maybe you could use them. Choice of topic, sets or logic, right. I mean, like, in your guys' opinion, what, like, if you were to start a proof book from scratch, like, would you like to start from logic or would you rather start from sets? Because I think, here, the way I think about it, right, I feel like if you were to think about math as sort of like magic, right, or just magic building, right, I think of logic as... because now I'm getting imaginative now, because I like it, because math itself is sort of like magical in a way, because you don't really need any physical apparatus, you just basically need your imagination to make it. So with logic, I feel as if it's sort of like the flow of thoughts, or the flow of I guess the flow of mana or something, or chi if you want to be like specific, I guess, or something like that. I know I'm just making stuff up, but this is the better way of solidifying in my head, because it allows me to engage the child in my head in addition to trying to make it so that it fits in a more abstract yet imaginative fun way that you would probably like see in movies or books or whatever. I start from logic for sure. Gotcha. Yeah. I don't discourage that. And I think with sets, if you were thinking about a magic system, I would say sets are not the spells. But I would guess this. I would have to say the physical manifestations or the events of the magic. So I guess the physical parts of the magic, like maybe the wand or maybe you know, your potions or whatever. The physical parts of the magic. Sorry if my handwriting is not really clear. Sometimes, like, when I write, it gets really smudgy. But I know that probably is not the way, like, people that know math would probably explain it. But I guess that's the way I kind of want to bring a little fun into it. Thanks, Famish. Actually, like, since you guys are here, I wanted to ask you guys what's the best part of your day so far. Just want to help start you guys on a good note. Sets are like the names and names in the name of the wind. Yeah, probably. Yeah. If you know the true name of something, you can control it. Don't. I haven't read the book. No, it's okay. I probably have. I haven't read that book either. I just know that that's supposed to be the plot point. Oh, you like the which analogy did you like, and Stunky? Did you like Fluffy's analogy or mine? It's okay if you pick either or. Very Gaelic. Hopefully I pronounced that right. Both, but I was referring to Floyd. Yeah, yeah, that's actually a very unique one because I don't know that many movies or shows. So, because the thing of it is that when it comes to like learning math and physics, people try to turn it very technical. So, if I were to take anything from pop culture, I feel as if people, when they get into math and physics, they explain it from a Star Trek perspective, where it's like you have to know the ins and outs of Star Trek and you actually have to be immersed in that universe. But, you know, Star Trek is an acquired taste, and, you know, you also have people that are into Star Wars, and Star Wars, they don't really go into like the logical building of, like, you know, what makes science in some ways. It's a good movie series, don't get me wrong, because I was a fan of Star Wars, but they mostly like to tap into, like, I guess the sci-fi setting of it, but they don't really go into the science of what makes a lightsaber, or what makes, like, you know, a spaceship, like, fly a certain way, you know. But if you watch shows like Doctor Who, for example, Doctor Who kind of takes the sci-fi element, but it turns it in a way where it feels as if it's just, it feels like it's not, you know, it's about space and time, but it feels as if that you don't really have to know it to actually enjoy the series. But at the same time, it doesn't take liberties on making the audience feel left behind when it comes to explaining deeper topics like other dimensions or parallel universes and stuff. And I feel like that's the way I want to actually engage with math and physics, because it allows you to feel as if you're creating something out of nothing. And I think that's how, like, I think that's why people get into physics when it comes to math, or at least theoretical physics, because the equations themselves allow you to get possible predictions of behaviors that can occur in the physical universe, which you can't fully tap into if you don't have the machinery or the energy to interact with it. So, you know, but then again, that it can also make people that are theorists very big-headed. Like, they think that all they need is just the equations and just the certain conditions or boundary conditions, and they could be like, oh, I can just write this and then ta-da, I have this new prediction. Now just prove it by experiment. Like, go get the funding, experimentalists. Like, they're just cogs for, like, the theorists to basically control which in actuality, like, you know, we know that good science is done by collaboration with others, you know, making sure that everyone is treated with the respect that they deserve, despite what the contributions may kind of like are perceived to be by society and by the scientific community, or the mathematical community for that matter. I like the idea of where math is a magic system because every time I learn a new theorem about dynamical systems, I feel like I access forbidden knowledge. Yeah, exactly, about infinity. Yeah, that's what I like about math too, is like you engage into infinities that you never thought you could be able to reach because like nobody knows what infinity is, and infinity is not a number. It's just like an abstraction of like what we don't know. And I think that's the fun part about it. Yeah, Star Wars is Western in space. Well, yeah, it's West. Well, I would have to say it's a Western in space with samurais in it. I would probably go that far. Um, let's see. No shade. That's objectively what Episode 4 was trying to do. Right. I actually started doing high school level physics. Nice. Maybe we can study together, Famish. Um, it's easy, at least for me. Yeah, because like the thing of it is that the one thing about physics that intimidates me is that you feel like you know the equations, and you feel like you know that with the equations you can apply them to the problems, but then when you get to the problems, you realize that it's not just the equations. You actually have to think about the physical problem, and what kind of is like a reality check for people that learn physics starting from a mathematical background. It's not just about plugging numbers in, it's about like just trying to think about how we can use the equations, manipulate them in a way to give us something, but at the same time there's also parameters, so you have to include those in the equations. And sometimes the mathematical relationships like get blinded by the science, so you forget that there's certain mathematical relations that are in the equations. Like one example is I remember I was doing this one problem where it was like I believe it was about rotational motion. No, uh, circular motion. Sorry, why did I say rotational? And I think when it came to the equation of motion, like when it came to the position of a particle, I forgot that you could actually take the difference of the angles, like the original angle minus the final angle. I forgot that you can actually do that, and that I ended up messing up a problem because of that. But you know, like that's why in physics you kind of have to face the fact that you won't know everything, and sometimes it really hurts your ego, and you feel like you feel like you love the subject, but at the same time you feel like you're an imposter because you're not good at it. At first. Because like with me, physics problems do intimidate me a lot. I really love this feeling. I wish I could put myself in the headspace of to experience it more often. It's not even really a fantasy. It's just the truth viewed from a more wondrous angle. Yeah, exactly. And the thing of it is that with math, I feel like you have the, even though it is more logically built and it's mainly meant to be more technical and abstract, I feel as if you can kind of implement a little bit of a magic system in it, because it gives it a sense of this mysterious aura where it's like, it's a game, but the game itself doesn't impact anything in reality. And I guess that's why people find it fun. At least for me, I find it very interesting, because you just need definitions, and you can use those definitions to create theorems and relationships, and those theorems and relationships lead you to bigger ideas involving like what is the same in every regard when it comes to like symmetry and all that. So the old philosophical question, is math invented or discovered? Yeah, and I think that's a really good thing to ask, actually, because the thing of it is that we don't even know what constitutes actually what would be we wouldn't know what constitutes as what really math is, because it's like that old was that, I don't know if it's a saying or whatever, but if you hear a tree fall, if no one is around to hear a tree fall, does it make a sound? And with math, it kind of falls that same trajectory where it's like, if there's no humans to regard math existence or to make math proofs, does math truly exist? And you could probably make the argument that say math would still exist. It's just that it just wouldn't be, um, it just wouldn't have definitions in human languages. It would probably just be well known within nature, such as why is it that there's more prey than predators, for example, or why is it that despite the fact that there's always going to be animals hunting animals, right? If they're carnivores or whatnot, then why is it that the animals that hunt don't grow as fast as animals that that are mostly prey and eat plants, it's stuff like that. But if you were asking me that question, I would say, for me, I feel like I lean towards more to the Discover crowd, but at the same time, I know that math has to technically be invented by someone's head to basically create a theorem. So, for me, I feel like it's more discovered, but I'm just more of a wishful thinker and thinking that there's a mathematical realm of ideas, like how Edward Frankel puts it, where there's this abstract realm of mathematical ideas and they're just there just to be discovered. You can invent a definition or a method. Yeah, you can also invent axioms, like if you basically start off from scratch, yeah. But then you can discover the results and implications as well. Yeah. And I think that's why axioms are invented. Things that become necessarily unnecessary biological implication feel more discovered, especially ones that are so subjected in the work so that there's not to be any other way to do them. Yeah, right. But there are definitely things I've done that feel more arbitrary and those that feel more invented to me. Yeah, I guess it depends on the perspective. I think I'm Marcel Proust, if I remember correctly, talking about the theory of a rhythm, which forces poets to come up with their best work. Okay. I definitely don't believe in an actual realm of mathematical ideas. My point of view is it's more about intent. Right. Yeah. I mean, everyone, there's no right or wrong answer to that. And actually, I think if you were to pose that question to someone who is from high school, I think that's a really great philosophical question to ask, because whether math is invented or discovered, it's kind of irrelevant. In fact, I think when people are asked this question, or at least mathematicians are, they really want to invent a word where it means both. Where it means it's invented, but it's also discovered. But it means it at the same time, and it's just simplified in one word. But I don't think in the English language we have a word like that. But maybe in another language we probably will have a word like that. So, or maybe call it serendipity or something. I don't know. You come across it, but you kind of invent the concept. I don't know. It's whatever. But in my personal opinion, I feel as if if we can just invent, if we can use math to invent the numbers and stuff, and show that to people that are younger, people that don't know mathematical proofs, we can use it. The problem is that when you actually go into learning about how the basic stuff that we take for granted in arithmetic, such as why is it that the integers are the way they are, why is it that the rational numbers are the way they are, you begin to see that there's a lot of complications on how to invent them, to actually create them. Because if you look here for just the integers, we have to invent the integers to create subtraction. And the thing is that it's about 15 pages long to basically just prove that the integers exist, let alone the operations that they need in order to maintain this sense of this sense that it makes sense for us to use it in calculations or arithmetic, like for basic operations and subtraction. Because if you were to explain it to an elementary school student, I understand why we don't teach it this way. Because you have to teach an elementary school student about equivalent relations and equivalence classes, and I think that is something that will go definitely over their head. Even I don't fully understand like equivalence relations or equivalence classes just this yet. I remember Sascha, like one of my friends, who tried to explain to me about these concepts. I felt as if when he was explaining it to me, I kind of understood it, but then when I like stepped away and didn't listen to the content for a long time, I kind of forgot it. But then at the same time, I knew that we need something like equivalence classes and equivalence relations, or relations leading to equivalence classes. So that's something that I think a high school student could actually try to engage with, because if you guys are familiar with the book Book of Proof by Richard Hammock, he does a really good job of explaining like anything involving like intro to proofs, and I think a high school student could pick that up and basically start learning from that. Of course, real analysis is a totally different story. What is this? Arithmetic and the integers, right? Yeah, so yeah, it's about like 15 pages just to prove all of that. But I left it in the description down below if you guys want to check it out. And if you guys need me to put it in the chat again, I will definitely put it in the chat again. But that's how to inspire people to basically get into like basically like understanding how things are constructed. The integers are about 15 pages, yeah, and the rational numbers are about 20 pages. And I don't even know if they took liberties to cut some stuff out, because like if you guys want me to actually go through these like in another stream, I guess I'll be happy to go through it, but it will be probably me just reading a lot, and I felt like I haven't been very productive in actually writing notes for you guys. All of it is just basically just me just kind of like talking about it, but that's how I'm into the subject actually. Oh, hello. I'm trying to pronounce your name. Shitoran? Shitoran? Hopefully I pronounced it right. If I mispronounce it, I apologize. If you would like me to shorten your name so it's like easier for me to address you, you know, just tell me how you want me to shorten your name, or you know, which name do you prefer to go by. What's the best part of your day so far? Yeah, I feel like I haven't been talking much about like just like technical math issues or ideas. I'm just basically just talking about my love for the subject. But I haven't done anything that's kind of technical. Yeah. Oh, okay, I pronounced it right. That's good. That's good. So yeah, that's how I think about logic and sets actually, because it's just based on feeling. It's not really based on like, you know, based on a technical explanation. That's how it feels to me, because I feel like logic tells like how the math ideas are supposed to flow as you write the proofs down, while sets are the tool, like the parts you need to explain the logic. And I think that's the thing that makes it very, very interesting when it comes to proof writing. Of course, building those ideas, that comes with another territory. Excuse me. The thing that I have fun with is the De Morgan laws. Those are fun. Like, it took me a long time to actually try to understand like De Morgan law proofs actually, because I would have the bad habit of using multiple variables when in fact I should be just using one variable to explain a De Morgan proof. Like, let me see if I can find one for you guys actually. I probably should like, let's see. I have too many files open. Let's see. Let's type in Book of Let me just open this. Open with Brave. There we go. Let's see if we can find a De Morgan proof, and let's just see how we can do with it. Because the thing that really kind of gets me off on like basic proofs, I know I should be doing the books and the problems. The one thing is that when you start learning proofs at the beginning, or at least like the beginning of learning proofs, you learn logic and sets, it gets really, really boring in the beginning because you're always doing like, I guess, like trying to write things instead of just proving things. And it can get a little trivial. I'm not saying I should. I'm not saying I don't want to do it. I'm just basically saying like, how many problems do I have to do until I actually like can move on? And I think that's the hard question. But then again, you don't want to move on too fast, because if you move on too fast, then you're basically not ready for the next step. But then again, some people move on real fast and then they encounter a wall and they're like, okay, what do I have to go back to like learn the basics of this thing? Maybe it's in logic. I don't know, because I want to find like an actual De Morgan law proof here. Let's see, logic. Complements, Venn diagrams. Maybe it's in Venn diagrams. Draw a Venn diagram. No. Maybe I should just ask AI. I should probably just ask him. Just bring this up here. Guess I'll ask Claude. Provide De Morgan law problem. While that's cooking, I'll get back to what you guys typed. I tried to identify all the concepts and feel are important to learn and probe my understanding of each identity relevant problems along the way. Yeah, I probably should adapt that. It's also good to give yourself permission to go through the book in non-linear order. Yeah, I have to learn to get out of that habit, like, you know, going linear order, because whenever I go in linear order, sometimes it gets boring midway and I lose interest. Because later information may give you more context for previous problems, vice versa. Yeah. Keep going back and forth through the chapters and read ahead. When I'm confused as to why something's important, see where it's coming up later. Yeah. I think for me, I just get a little bit paranoid about like reading ahead and then suddenly I encounter something. Okay, so we got a problem. So prove the following: that I'm pretty sure like when you guys see this is going to be pretty basic. Now I'm probably not going to write the proof exactly right, because you know, with proofwriting you also have to kind of like edit your work and make sure it's legible for people to read it, and sometimes I write things in the wrong order, so just be aware of that. I think for me, I kind of get the structure a little bit though. Okay, so let P and Q be sets and X is an element of oops, no. is an element of not P and Q. Now, I don't want to say by definition, but like, this is the part that I probably haven't mastered because obviously I'm not very good at it. It's like how to make it so it's like a proof that's presentable. And that's the hard part. That's the hard part usually. So thus, X is not an element of P and Q. Not an element of P and Q. Meaning, oh, that is so scrunched. I don't like it when I write it like, meaning that X is not in P and X is not in Q. But X is in not P and X is in not Q. Okay. Now at this part, and I think we're supposed to like not end the proof, but basically show that one side of the proof has been solved. So, and I think you're supposed to write in a specific way. Showing. No, actually, that's terrible. I don't like that. Did you guys type anything more? Oh, okay. I thought I missed something in chat. Because I don't want to write thus again. And I don't want to write. Usually for me, I developed the habit where I write therefore at the end, like at the way ending. But if I have to use it, I might use it. Whatever. As long as it's not repeating on the next sentence, I guess it's fine. Therefore, and I know I'm not supposed to use this sign yet, I think. I think I'm supposed to like make it like a subgroup or something. Or subset, I should say. If I'm wrong, please correct me. Because I know I will make a lot of mistakes doing these things. After meaning that sentence, if you're not in Q, then you're not in, even if you're in P. Yeah, I knew I was going to make mistakes like that. Let's see. I feel like you may set yourself up to use the De Morgan rule for sets in the proof for the De Morgan rule for logical operations. I'd be careful to make sure that you know how to prove at least one of them independently of the other. Yeah, probably. You're not in Q. You can be in P and not in Q, or you can be Right, okay, so I should be writing that right. So it's like, and I think that's the frustrating part when you're like doing math proofs, is that you realize that, oh wait, there's like certain things I have to like keep in mind. Yeah, because like what you guys pointed out actually makes a lot of sense, because P can be true and Q could be false. So it's like that type of scenario. So now I gotta think about how to write that in a way. I don't want to make it too wordy, but at the same time, like I gotta figure out how to phrase that correctly. I don't know if that's a case by case basis. I don't think so. Yeah, I get what you guys mean. Like, basically, X could be in P, but it probably might not be in Q. Thus, it's not really like in this particular set in general. Which is why I drew in the truth table scenario, where it's like the one thing is I'm trying to figure out how to write it in a way where it's like the sentence form, like how to write it so it's like. But at the same time, I don't know if I have to write it as a case basis, where it's like there's in case one, X belongs in P, while X does not belong in Q. So it's like that type of thing. It's like when you're writing an essay and you just don't know how to write the essay because you're like literally thinking about how the teacher's going to respond. And I think that's the scenario I'm in right now. You write out all the things that could be true in the big or statement, and then some things will cancel out. Basically from the truth table, yeah. Because I think what I'm struggling with is like, since I know you guys know how to write it, I get intimidated, and I'm like basically trying to do you guys I'm trying to make you guys proud on like actually writing the correct statement, like trying to write it correctly, and like I'm getting a little bit I guess like not stage fright, but like kind of like observant because I know I'm gonna get criticized for it. Like right now I'm just trying to draw up exactly how I should write it, because I feel like I know how to set it up. The thing of it is that I don't know if it's logically binding. That's the one thing, because I know I have to start from basically explaining this and leading this to lead to here, and then like when I do the next paragraph, I have to do it from starting from here and then going to here, so proving both sides. Like I know I have to do it with the variable X. The only thing is that writing it in a way that's sort of like mathematically coherent and logically coherent, that's the thing that I think is getting me a little bit frozen to write it, because I am trying to write it in a way that's proper. And I think I'm trying to be too perfectionist here. Because I know how the setup goes. It's just that writing it in a way where it's like the sentences are coherent and logically binding, that's the thing that's intimidating me. because I don't know if I should write it as possibilities. Like one possibility, X could be in P, and X cannot be in Q. Thus, like X is in, not Q. And another possibility is that X is not in P. Well, X is not an element of P. Thus, X is not in P, and then but then again, it's an and statement too. So it's like if it's not in this part, like basically we know it's not an element in this particular part here. I usually try to do the let's see. I usually try to do is use the setup as a writing outline for my proof. Okay. Yeah, I don't want to like look at the way it's supposed to properly be written because I don't want to like do myself a disservice for that. Maybe I have to write it like this. If X is an element of P, but X is not an element of Q, yeah, I don't want to write thus all the time because like part of me just want to write thus, but I know that's not a very coherent way of writing it. Then X is an element of not Q. If X is not in P, but X is in Q, then X is in not P. And if X is not in P and X is not in Q, well then again I could have probably just wrote this sentence alone, but that's kind of like the what ifs actually. But I feel like it's too wordy. I mean, the logic kind of makes sense, but at the same time, I just don't like the way it looks. Because I feel like this proof is supposed to be shorter than that. And this is only the first part of the proof. But then again, it could be just considered an outline. Hey Sascha, how's it going? What's the best part of your day so far, my friend? I'm just trying to review a De Morgan law proof. Like, I get the setup, it's just that, like, writing it out, I haven't done it in a while. And I sometimes forget that I have some logical hurdles that I haven't fully bypassed. Hello, B Lumen. What's the best part of your day so far? Okay. Maybe I have to use this to explain this part. Maybe I don't really need, like, I mean, not that part. This not this part. This part. Because I mean, technically, this would mean that X is not an element of P and Q. Like just this whole thing together, but at the same time, it could also mean like these other scenarios. Trying to restart high school math, nice. Like what math are you trying to like engage with? Like algebra, geometry, calculus. Yeah, because I feel like there's a way to make this like just basic. Because this feels too wordy to me, but at the same time, I'm trying to make it logically coherent. Because there is a scenario where it's like X is in P, but it's not in Q, thus it's not supposed to be in here. And I feel like these parts are helping the case out, like basically just. So end of it. Now I gotta think about if this is logically coherent. Vectors and 3D geometry, nice. So I'm guessing it's multivariable calculus then. That should be fun. Like which part of vectors and 3D geometry are you studying now? Is it curl, divergence, the gradient, or is it something more than that? Like are you actually on like double integrals or triple integrals? Maybe I have to take this part out because it says or. So. Remember, Sastra says like if whatever is on the other side, you, which is on the other side here, you try to make the proof reflect that side. So let's see. But they're not set here. It's basic 1, but a little more advanced than high school level, but just a tiny bit and not double or triple integrals. Oh, okay. So are you just learning calculus, or are you just starting to learn vectors? Unless you're taking linear algebra. They are truth values. Right. Yeah. Maybe I'm looking at it as sets, I guess. I don't know. Because I guess P and Q are also considered like statements too. Like for me, I'm like I understand like writing the truth table like basically will probably make it a little bit more coherent, I guess. It's just that I'm getting what you guys are saying though. Because I know that basically X can belong to P and or X can belong to Q. Like that I'm not struggling with. The only thing that I'm struggling with is writing how we can use these two sentences to basically say, oh, to give the or part. And the thing of it is that I'm really struggling with how to make it in words. That's the only thing. So do I have to write this proof, and so do I have to actually just erase this entire proof then, practically, if it's just logic? Because the reason why I'm writing it this way is because like this is the only way that I've kind of like learned how to do De Morgan proofs. Just like by using X as like an element of this, and then having it result in like the other side here, and then we have to do it the other side with the next paragraph. So is there a different way to write it? Like using logic, I mean? Like, do you just have to write the truth table and that's it, or what? Actually, I have to look at the what. Hold on. Because I don't know what the AI said. What did the AI said these were sets, or were they saying that this is a statement? Gotta take a look here. Approve the following. Prove this using analytic logical equivalence chains, citing a justification for each step. So they don't really tell you what P and Q are. Because I just typed in a De Morgan's law proof problem. I didn't really like tell it what we were using. Okay, if you guys are saying it's a logic problem, then okay. Then I guess we'll just erase it then. Because I was just using it as a set, like using it for sets. Because I was assuming they were sets, and but okay. Guess if we're gonna do it with the truth table, then we're doing it with the truth table, I guess. I think we gotta move this over here. Hopefully you guys can still see it though. Yeah, and this is just only two statements. Like, imagine if you had to do three. Three is just like, ugh, like, gotta constantly write over and over again. just do the other one for funsies. Okay. So we got this. That means it's false. I mean, yeah, that's false. True, true, true. This one is false. False, false, true. And what we want is basically this one is the same as this one. So is it? Yes, it is. So these two are the same. Yeah, you use the truth table for simple equivalence. Oh, you typed a lot, Sasha. Let's see. It's possible to write a similar flavor proof as you were trying to use constructive logic, but it's more easy to write down the truth table. Yeah, because the problem didn't clarify if it's statements or sets. Yeah, usually you use truth tables for simple equivalence, but once you have more tools in your toolbox, you can use that much. No, it's okay. It's okay, Beluance. Like, for me, I don't look at it as like, oh, I'm strictly doing something. But if I get too concentrated on a problem and I don't see your thing in chat, I will go back to it. I'm 0 in maths. Basically, I never liked it since grade 1, but I love physics and I need to finish a whole high school maths in just 2 months. I'm ready to do all the things that just don't know how. That's fair. Yeah, like if you like at the beginning of the stream, I was kind of talking about that actually. I'm kind of not great with both. I really like both subjects though, but I constantly struggle with it. So it's okay if you feel like, you know, like you're kind of feel like you're like behind on something or on stuff, because I feel the same way. Whenever I do a mathematical proof and like chat that knows more about proof than me tell me that I'm doing something wrong, I feel as if, oh my gosh, why didn't I do it the way that chat wanted me to do it, you know? So it's a lot of pressure. It feels like a lot of pressure because you love the subjects, or at least you love physics, that you want to be good at it, but you realize that there's another skill you have to implement in order to be better at it, and it's always going to be difficult. It's always going to be difficult to actually try to implement something towards something you're really interested in. So I guess like my question to you is that what made you get into physics? That's the question I'm going to get into. And do you plan to do, like, if you like physics, do you like it for the experimentation of it, or do you like it for the theoretical part of it? That's the thing I think I should ask. Because, like, are you in high school, or are you just someone that's into physics and you just want to start learning, like, the maths to understand physics better? Like, you're not a student, that's what I'm asking. What do you mean by a small story? Or a short story, I probably should say. Because, like, for me, whenever I do a physics problem, I would probably rush in and start doing calculations right away, and that's not the thing you should be doing when it comes to physics. That's like a bad habit that I have when it comes to physics problems, because you feel as if when you're like engaged with the physics problem, you feel like you have to engage with the math more, but in actuality, like, you have to actually know the problem. And when you know the thing that makes you paranoid is that you start questioning whether you know the problem deep enough. And I think people that do math also have that issue when it comes to trying to understand the deeper essence of like a math problem. I just noticed something. I'm just gonna quick. Because I noticed there's a lot of dust by like my computer, so I just feel like I want to like wipe that down. Because I'm like, oh my gosh, there's a lot of dust. Uh-oh. Why did my camera go off? Oh, okay. I guess it's because like I have to be in front of you guys in order for it to interact. Because I do have a broadcast program, so it has to read my face. Sorry about that. Yeah, that was just bothering me a bit. I just felt like I needed to clean my space before we move on to that. Just passed out actually, and waiting for the result. Maybe 30th of April. I will get the results in just 2 months, and I have my Research Institute exam. So yeah, well, about the story. How do I get into physics? Oh, okay. Well, I think what inspires you about physics? Like, do you want to know more about space-time? Do you want to just know why things behave the way they do on Earth, such as like why do objects fall to the Earth? There's like a lot of stuff that can get you into physics, but I would say like if you really want to be good at it, like most people will say like the only way you get good at physics is by doing physics. And not just reading the stuff, but actually engage with it. You can actually do like fun experiments at home. There was one experiment that I did where you actually measure the speed of gravity by taking your phone. If you take your phone and you put it, if you record, there was like a fun experiment where you fold a piece of paper in half, and you put a pencil on top. Like you fold it like a book. Like you basically fold it in half and you like put your pencil on top, and you record on your phone, and you record yourself hitting the paper really fast. When you hit the paper really fast, the pencil will obviously start to drop. If you know the frame rate of your phone and you actually turn it into slow-mo mode, where it's like the pencil is falling slowly, if you actually measure the frame rate and knowing how many frames you get per second, you can actually calculate the acceleration due to gravity with that. So that was one experiment that I did, and that was pretty fun. You can do interactive stuff like that. I don't do as much experiments as I probably should, though, to better understand the physics, though. Yeah, I think like that's the best way I can kind of say to get into physics. You have to really engage with like either the physical world or just engage with problems involving physics. Like if you ever notice like why cars move, you have to start asking like why do the wheels move? Why is it that the wheels, when they move, like why is it that they are able to make the car move forward or backward? And you have to start engaging with questions like that, and then it leads you into things like friction and all the basic stuff mainly. Because like memorizing the equations is not enough, because I've kind of had first-hand experience about that, where it's like, oh, I got the equations, now I could just implement them in problems. That's only part of it. You just have to know how to use them, and knowing how to use them is a little bit more difficult, because you have to actually know what the problem's talking about. And sometimes the problems are very particular that you kind of forget a detail here and there, and that's the thing you kind of don't want to do. So usually you would just look at a problem first, and then you have to ask yourself, what are the parameters of the problem, and what is this problem kind of like telling us about like this physical event that's occurring. But that's the best way I can basically state the case involving like how to get into physics mainly. At least like on a personal level. Like if you're like trying to get into like physics as a profession, I would say like once you do the studies and everything, I would say like just try to connect with your professors or people that are connected in the physics community, and see if you can do like I guess like help them with their experiments or help them with like stuff that I think like most uh, I guess like most undergrads would do to help them in their research. So hopefully that helps. Oh, hello. Jess. Yes, Vardan Sokar. I apologize if I mispronounced your name. You're from India. It's great. Cool. My maths is weak. CBSE class board 10. I don't know what that is. I'm guessing that's like part of the curriculum in India that you're in. So is it are you doing calculus? Are you doing algebra? Are you doing geometry? What branch of math are you doing? Geometry I actually have to get back into because I have I barely remember, I remember the formulas that you would implement for certain shapes. The one thing I don't remember about geometry is the proof writing, because I never remember doing proofs in geometry. Because now whenever I talk to any of my nieces and nephews that are in high school, they are doing geometry and there's proof writing in it, and I'm like, wait, what? I don't remember proof writing in geometry. So it's the educational board for 10th grade 10th students. Oh, okay. So do you know what type of math you're doing? Because if it's grade 10, then I'm guessing you're in high school. Because India's math curriculum is no joke, though. I will say that for sure. Funny story. I'm not always a good student. My real name is Newton. So when I was in grade 6, my teacher gave me some homework. Actually, I did not do. And on that day, he said that your name is Newton. You do you. Do you? That's funny. That's a pretty funny story. But I mean, at least you're getting into physics though, because now you get to learn what your your name, the person that shares your namesake basically discovered. Because gravity is no joke, actually. Especially when you get into general relativity, which I'm nowhere near. Because the fun part, I think, with physics is that when you realize that there's certain branches of math that you can actually use to explain physical phenomena, it gets a little bit cool. Hello, Prince. Honestly, I don't know what that is. All I know is basically basic algebra, geometry, and a little bit of calculus. I'm not sure what's on that particular criteria for that. Yash. Usually, when I see a question, I read it and see if I understand what the question is asking. Because I'm guessing since you're in 10th grade and you're from India, I'm guessing it's going to be calculus based. You're doing derivatives and integrals, or are you doing vectors and what's just doing vector calculus? Nice, Prince. Awesome. Actually, I feel like I have to engage with calculus, vector calculus. Because I know things like the divergence, the gradient, and the curl, and the Laplacian, but other stuff involving vector calculus I haven't engaged with. So I probably should engage with that more. Because it would also help me with tensors. Because like I want to learn tensors so I can learn a little bit more about general relativity. It's one of the toughest exams here. Oh dang. I mean, I can probably help you with some basic stuff, but I don't know if I can help you with like extreme exam stuff. That's the one thing I don't know if I can, but I can try my best to. Because usually with tough exams, they either try to trick you or they try to make you like question what you know, and that's the thing that really is annoying. Like I know they're trying to make it so that you know the stuff, but at the same time, it's like you don't need to trick a person to like to ask what they know. Do you even know who he is or what he did? He said two not good stuff to me. But since that day, I was very bad at physics. Oh, okay. So, I mean, are you generally asking me that question, or are you just basically just being hyperbolic about that question? Because, like, if you don't know who Sir Isaac Newton is, that's fine. I can probably explain it to you if you're genuinely asking that question. Like line integrals. Yeah, like not line integrals, yeah. I won't say I'm good in general, but good to get high marks in class. Yeah, but you know, like if you're trying to learn physics on your own or trying to self teach yourself physics and math, the grades are not really the issue. It's just basically just trying to ask yourself if you really understand the content and the subjects. Because for me, when I learned physics, like things like distance, velocity, and acceleration, that kind of took me, like I had to really imagine how those things work together without the math. When I see it set up in the math, like when you actually see the equation for the final position compared to like the initial position, the initial velocity, and the initial acceleration, you begin to see that the pattern is that it's written like a quadratic equation, but then you end up wondering, why is it set up that way? And when I kind of figured out why it was like that, it made me think about like other things in life, such as instead of like having position, acceleration, and velocity, what if it was like the rate of growth of a particular money market, right? Because like you would have to say like, how much money am I gaining every second per second, or like how much money I'm gaining per second, and then like how much money did I start it with? And you know, that's like a basic mathematical pattern you notice. I always topped school in science, social science, English, and state languages. Nice. Search for, but it's so easy. Okay. Let me just like look that up on Google actually, because like I know like I get a lot of people that are from India that basically come into the channel, which I'm thankful for. And you guys take really hardcore exams, so let's see what this is. Covers chemistry, biology, and physics. Okay. Just gonna take a look at what you guys have experienced. Okay, chemical reactions and equations, acids, base. Wow. You guys cover like a really good portion. There's something on electricity. Let's see. I'm just gonna click in to see some. Oh, let me show me what the questions are. Here's a PDF version. Oh, this kind of reminds me of what I would read in a high school textbook. I mean, the pictures are nice. It's kind of funny that like textbooks, they have to have great visuals, otherwise they're going to be completely monotonous to read. I cleared the JEE mains and I'm in the National Institute of my state. Nice, nice. Was preparing for my ends. Oh, okay, that's cool. Well, it seems like you guys are getting proceeding well into your journey when it comes to like maths and physics. At least I hope so. I'm taking arts now. Oh, okay. There's nothing wrong with taking the arts. Actually, the arts can probably help enhance math, actually. And I think some mathematicians really appreciate art because of the symmetry it can illustrate. If there's like, you know, like if it's like one of those perfect paintings instead of modern art, because modern art is like kind of like all over the place sometimes. But, you know, there could be a mathematical pattern there, we just don't know. Or like, you know, I probably haven't observed the pattern. Which damages the car, so yeah. It's good to think. Yeah, it's good to think, yeah. Right. Okay, I think that will do it for today's stream, guys. I know it's just me just talking, but, you know, hopefully you got something out of it. If you're watching this on YouTube or YouTube Shorts, you know, drop a sub if, you know, you got something out of my little ramblings there. If you're watching this on Twitch, you know, hit the follow button. It's always appreciated. And also, if you're watching this on YouTube, you know, hit the like and leave a comment down below if you're watching this afterwards. I don't know how often I'll be streaming on my math channel because, like, you know, it's just me just talking or just doing a little bit of math. So, you know. I'm not sure what that means. Be lumen. No, I appreciate the compliment. I try to be at peace most of the time. For me, I know I'm not good at math and physics, but I just love the subjects anyway. Because, like, you know, with math proofs, you feel like you're creating ideas, while with physics, like, if you understand math, you basically kind of create the... you basically feel like you're actually using math to create the universe in some way, even though it's just basically you trying to solve like what the math is telling you about the physical system. So yeah, always appreciate you guys. Thanks for stopping by. The next time I stream, I'm not sure when that will be, but it depends on like what comes next, I guess. So maybe we'll probably do something simple like more calculation-based math, like vector calculus, or maybe we'll go into algebra or geometry. Who knows? But thanks for dealing with my ramblings, guys. And always remember, everyone is precious. You guys are just as precious as everyone else. And I will see you guys in the next stream. So take care, guys. Bye-bye.